Limiting reactant problems crush students on tests, not because the math is difficult, but because they compare the wrong numbers. In this video, I'll show you how to always find the limiting reactant, even when both reactants are given in grams, and we'll finish with a problem that shows how to find the leftover reactant. The limiting reactant is essentially the one that runs out first. It limits how much product we can make. One important thing to note about this is to always compare in moles, not in grams. What this means is we want to compare our products that we make in moles rather than in grams, because different substances have different molar masses, so it won't give us a proper scale. Let's look at our first example. If we have 2H2 plus O2 yields 2H2O, and we're given 10 grams of hydrogen and 80 grams of oxygen, which one will be the limiting reactant? Well, our first step is to convert our grams to moles. So if we start with our hydrogen, we're going to go our 10 grams of H2, use our molar mass conversion factor of 1 mole H2 being 2.016 grams. Those grams cancel out, and we have 4.96 moles of our hydrogen. Now let's do the same for our oxygen. We have 80 grams of oxygen, and we're going to do 1 mole of oxygen over 32 grams. Again, our grams cancel out. We're left with moles of oxygen. 80 divided by 32 gives us 2.5 moles of oxygen. Now that we have them both in moles, we can look at mole ratios to see which one will be the limiting reactant. If we pick one of our reactants, say the O2, we can do a mole to mole ratio according to our equation to see how much H2 we'll need to fully react with the 2.5 moles of O2. Well, we have a 2H2 to 1 O2 ratio. So for every 2 moles of H2, we need 1 mole of O2 to fully react together. So if we were to do this conversion, we'll have 2.5 moles of O2 times our mole to mole ratio of 1 mole O2 to 2 moles H2. Our moles O2 cancel. We see that if we want to react 2.5 moles of O2, we need 5 moles of H2. Well, how many moles of H2 do we actually have? We only have 4.96. So we need 5 moles of H2 to fully react with our 2.5 moles of O2 that we have, but we don't have enough, meaning that H2 is our limiting reactant. Here's where most students mess up. They compare the grams directly. It only works if the molar masses are identical, which they almost never are, which is why you should convert to moles first. If we were just looking at 10 grams of hydrogen and 80 grams of oxygen, we would think that there's much more oxygen and there will be a lot left over. But it turns out they were almost the exact same amount. Very, very little hydrogen was missing for all the oxygen to react. So it was much closer than we anticipated, and we only knew that by converting to moles first. Let's look at another example. This time we have N2 plus 3H2 yields 2NH3. We're given 14 grams of our nitrogen and 6 grams of our hydrogen. We want to find the limiting reactant and then figure out how much of our other reactant will be left over once our limiting reactant runs out. So let's start with finding our limiting reactant, because that's what we looked at already. Again, we're going to do the same thing as before. We're going to convert our grams to moles. We have 14 grams of nitrogen, and we're going to do our molar mass conversion. So 1 mole is 28.02 grams. Grams cancel out again. We end up with 0.5 moles of nitrogen. For our hydrogen, we're going to do our 6 grams timesing our molar mass, so 1 mole over 2.016 grams, and we're left with 2.98 moles of our hydrogen gas. Now we're going to do our mole ratio again. If we were to pick our nitrogen, we see that the ratio is a 1 to 3 ratio. So if we have our 0.5 moles of nitrogen, we can multiply this by our 1 mole of nitrogen on the bottom and our 3 moles of our hydrogen on the top, giving us 1.5 moles of H2. So this means to fully react with that 0.5 moles of N2 that we have, we need 1.5 moles of H2. Well, how many moles of H2 do we have? We have 2.98 moles of H2. So in this case, our N2, our nitrogen, is the limiting reactant because we use all 0.5 moles of it and we still have some leftover hydrogen. Now let's figure out how much hydrogen we'll have left over. Well, altogether, we have 2.98 moles, and to fully react with the 0.5 moles of nitrogen, we're going to use 1.5 moles of the hydrogen. So all we have to do is subtract them, and we find out that we're left with 1.48 moles are left after finishing this reaction and running out of our nitrogen. For more detailed limiting reactant problems, you can check out the complete stoichiometry breakdown linked below. And if this helps, subscribe for more tutorials.